Target 3. Writing and solve, application problems with percents. So, number 11 says, write and solve an algebraic equation for the following questions. At an auction, you bought an antique table for $150. If the price of the antique increased by 8%, what is the new price of the table? So what we have to realize here is we've got a basic formula, which is the percent times the original equals the new. The percent, though, has to be written as a decimal. And we also have to realize this is not necessarily the percent that we're going to use, all right? We got to figure out if we're increasing or decreasing. So this says increased by 8%. Well, you always start at 100%. And if we increase it, that means we're adding 8%. That gives us 108%. So now, if I write my equation, 108%, and to make it a decimal, I move the decimal twice, and I get 1.08. 150 is the original price. That's what we paid for it. We want to know what the new price is. So we're going to do 1.08 times 150 equals the new price. Well, we just type in our calculator 1.08 times 150, and we get 162 equals the new price. And put a $sign on that. And there we go. Number 12. An electronics store reduces the price of a laptop computer by 20% to $1,020. Find the original price. So this time, they're reducing the price. Remember, we always start with 100%. Reducing means we're going to subtract, and we're reducing it by 20%. So that leaves us with 80%. So using our formula here, remember, percent written as a decimal times the original equals the new. Okay? So we've got our percent, which is 80, which if I move the decimal, we get 0.80 times, we don't know what the original price is. But we do know that the sale price was $1,020. So this $1,020 represents the afterwards, okay? So to solve this one, I just divide both sides by 0.80, divide by 0.80. Here, it's just going to cancel out. And we find out that the original price equals $1,275. All right, number 13 says if money is deposited into a savings account for 1 year earning 5% simple interest and $1,000 more is deposited into a CD at 6% simple interest, how much do we need to be invested in each account if you earned $115 in interest after 1 year? So we've got two things going on here, all right? We've got money going into a savings account, plus we've got money going into a CD. Now we know that the interest from the savings plus the interest from the CD will be a grand total of $115. Now the formula that we have for interest is I equals P times R times T, where I is interest, P stands for principal, in other words, how much money you invested, R stands for rate, but again, as a decimal, and T stands for time. So for the savings account, the interest is going to be X times 0.0 0.05 times 1 year. Now the reason we had to do x for the principal is because in this problem, it says money is deposited into a savings account for 1 year. We don't know how much money, so we give it a variable. Whenever we don't know a number, we can assign a variable to it. So that's the variable we assign to the savings account. Now for the CD, we're getting interest from the CD. Same formula, I equals P times R times T. So for the CD, our interest is going to equal the principal. Now for this one, it says the principal is $1,000 more. So that means we got to add $1,000 to the savings. So this is going to be X plus 1,000. That's our principal, $1,000 more than the savings. This one earned 0.06, still for a year. So if I simplify this expression right here, I get 0.05x, that's savings interest, plus if I simplify this expression right here, I get 0.06x plus 60. And that interest from the savings plus interest from the CD has to equal total interest of $115. So I could put together my like terms and I get 0.11x plus 60 equals 115. I'm going to subtract 60 off of each side and we get 0.11x equals 55. Divide both sides by 0.11, divide by 0.11. That cancels out and we get x equals 500. And that means x had to do with the savings account. So that means we saved $500, or we put $500 in the savings account. And again, it said the CD was $1,000 more than that, so we add 1,000 to that, and we put $1,500 into the CD. Number 14, very similar question. It says Peter invested a total of $12,000, some of it in a savings account earning 4%, and the rest in a certificate of deposit, which is just the way of writing out what CD stands for. And the CD earned 7%. How much did he invest in each account if after 1 year he earned $720 in interest? So we're going to set it up pretty much the same way. We've got savings plus the CD has to equal our total interest of $720. So all we got to do is use our formula. Remember, I equals PRT. We know that it's 1 year, so that means T is going to be 1. We know that for the savings account, it's 4%, and the CD is 7%. Well, 4% is 0.04 times 1 for time. We just have to figure out what we're going to put in there for the amount of money. Does it say anywhere in how much was put just into savings? And the answer is no. It tells us how much he invested total, but it doesn't tell us how much we put in savings. So we're going to, again, give that a variable. So for savings, we get X principal times 0.04 times 1, which simplifies to just 0.04x. For the CD, again, we know that it's for 1 year. We know that the interest rate is 0.07. We don't know is the principal balance. We don't want to use a different variable, because then again, that gives us too many variables, you can't do anything with it. What we should notice here is that Peter invested a total of $12,000. All right, a total of $12,000, which means if you think for a second, if I say I have $12,000 that I'm going to invest, and I say I put $2,000 into my savings account, okay? So I have $12,000, I put $2,000 into a savings account. What's left over to put in the other one? Well, you just do 12,000 minus 2,000. You find out you have 10,000 left over. So if I put X into my savings account. I have all leftover to put into my CD. Well, to find leftover, it's just 12,000 minus the X. That's what would be left over. And again, if I distribute here, I could ignore the 1 because 1 won't change anything. All right, we get $840 minus 0.07x. And I know that the interest that we earn from savings plus the interest we earn from the CD has to equal that grand total of $720 that we decided. So I could put together some like terms. 0.04x minus 0.07x is going to be negative 0.03x plus 840 equals 720. We're going to subtract 840 because our focus again is on the variable. We're focused on this guy right here. So that means we want to get rid of everything that's on this side that isn't that little x, which means getting rid of the 840, which we did using minus 840 because those are inverses. So that's going to cancel each other out, and we're going to be left with negative 0.03x equals negative 120. And then we're just going to divide by negative 0.03 on this side, divide by negative 0.03 on this side. Here they just cancel out because they're inverses, and we get x. Over here, negative 120 divided by negative 0.03 comes out to be $4,000. Whoops. So, if I look back to where I started the problem, I could see that x was what I put into savings. So my savings is $4,000. My CD was the rest of it. So notice for CD, we did 12,000 minus X. So for the CD, I'm going to do 12,000 minus the $4,000 that went in savings. That means there was $8,000 left over to put into the CD. All right. Next page.